the class of statistics. Today we'll learn about how to calculate the mode of a statistical data. After this, we'll go through the relationship between the three measures of central tendency, that is, how the mean, median, and mode are related to each other. So beginning with the mode. It is defined as the value in series of observation which occurs with the greatest frequency. Now what is frequency? The observation which occurs most frequently or most number of times in any data, it's called frequency. Now which occurs with greatest frequency, that will be our mode. So here, as you can see in the example, 3 occurs 2 times and 5 occurs 1, 2 and 3. Here, so 5 occur 3 times, so the mode of this data will be 5. Now we'll discuss the 3 model series. First is unimodal series. When there is only one mode in any statistical data, it is called unimodal series. Here, as you can see in the example, 3 occurs 2 times and the rest of the digits occur just once. So here the mode will be 3. Then it is called a unimodal series. Next is bimodal series. When two values occur equal number of times but with largest frequency. As you can see in the example, 4 occur 2 times and 7 occurs 2 times. So the mode here, 4 is also the mode and 7 is also the mode. So there are 2 modes in this data, so it's called a bimodal series. Now next is trimodal or multimodal series. When there are 3 or more modes in any distribution, then it is called as trimodal or multimodal. As here you can see that 5 occurs here 2 times and 6 occurs here 2 times and 9 also occur 2 times. So here the greatest frequency is 2, but of 3 cases of 5, 6 and 9, that are the modes. So it is known as trimodal or multimodal series. Now how to calculate the mode in any grouped frequency distribution. As you all know, this is the example of grouped frequency distribution in which intervals are provided to us and the frequencies. So how to calculate it? First, we'll locate a class with maximum frequency called the model class. The mode is the value inside the model class and is given by this formula, that is m0 is equal to capital L plus f1 minus f0 upon 2f1 minus f0 minus f2 into I, where L is the lower limit of the model class. F, for example, we have model class as 30 to 40. Then what will be the lower limit over here? 30 will be the lower limit. Then f1 is the frequency of the model class. Then f0 is the frequency of class preceding model class, means one step before the model class, that frequency will be f0, and f2 frequency of class succeeding the model class, means one step after the model class frequency, and I is the class interval. Now let's solve this example. This illustration states that the following data gives the information on the observed lifetimes in hours of 225 electrical components, and we have to determine the model lifetimes of these components. So here the data is in grouped frequency distribution, intervals are assigned to us and the frequency is given to us. So what we'll do, first we will check the highest frequency. What is the highest frequency over here? This is 61. So what will be the model class? 60 to 80. As 60 to 80. Now model class is 60 to 80. So what will be the lower class limit of model class? That will be 60 only. Now frequency is 61 of the model class, and this is the f1 and this will be f0, one step before preceding the model class, and this will be f2, one step after the model class. Now what will be the class size? It will be 20. Why? Because the difference of these things, 80 minus 60 will be 20. Now we'll put all these values in the required formula of median, mode. Now here, after substituting the values, L is 60, F1 61, F0 52, and H as 20, and like this. First we'll solve these brackets because here we are applying the board mass. After subtracting, we are getting 9 over here. 61 into 2 is 122, and subtracting this will be minus minus plus, and sign will be of minus 90 over here. Then we'll multiply this 9 into 20, and 122 minus 90 will be 32. After that, 60 plus 90 by 6 will 16. We'll divide 90 by 16, and we're getting 5.625. Then we'll add this thing, that we're getting the answer as 65.625. That is the value of mode. Now we look for the relation between the mean, median, and mode. The relation between these three is given by mode is equal to 3 times median minus 2 times mean. See, if we have the two values like median and mode are given to us, then we calculate the third one. Here is an example which showcases that the mode and mean are 32.1 and 35.4. We have to find the value of the median from here. So we'll substitute it in this formula and we'll get this 32.1 is equal to 3 times median minus 2 times 35.4. After rearranging, we're getting that 3 times median is equal to 102.9, or median is equal to 102.9 divided by 3 is equal to 34.3. See, in a similar manner, we can calculate any of the value if two values are given to us. I hope you have understood this topic. If you have any queries, please let me know in the comment box. Thanks for watching this video, and don't forget to subscribe.